So we now understand how the React agentic pattern used in LangGraph works. Now, to make it easy for us to create agents that use this pattern, LangChain has given us something called the create agent function. The create agent function. Sorry, that's just one E. The create agent function. This function uses LangGraph under the hood. It's a LangChain utility function, but it actually uses LangGraph under the hood to build the React node and edges structure, where you have the LLM calling tools, using their feedback as observation, deciding whether to run another tool or to just provide a final output. So we have create agent, and in this video we're going to be looking at the function signature for this create agent utility function, and we're going to be seeing all the parameters that it offers for us to effectively create this React single purpose agent. You use this to create only one agent. You can use this to create only one agent. There's also a LangChain system where you can use this function to create sub agents that you can now tie to larger agents that use this function. But this whole section is for creating single purpose agents. We're going to be looking at multi-agent systems in the next section. So without further ado, let us go in and look at the parameters that we can use to set up our agent using this function. And the first parameter is the model. Now the model, as you may have guessed, is for us to define the model that we want to use for our particular agent, for this particular agent. Do you want to use a model from OpenAI or from Anthropic? This is where you set it. Now there are two ways to set this model. You can either use a string, so you can say something like GPT-4, and this is going to be the model that we used for this agent. Now, notice that we didn't specify OpenAI here. We just said GPT-4. Now, LangChain is smart enough, and this function is smart enough to know that this belongs to OpenAI. This belongs to OpenAI. If you want to be more explicit, you can add this OpenAI suffix. According to the LangChain specification on how to write model names, you can actually prefix it with OpenAI. But if you just say GPT-4, yeah, this is smart enough to know that this is an OpenAI model. The same way if you just say Claude. If you just say Claude and you pick one of the Claude models, they do have long names, and I can't type that off my head right now. But yeah, something like maybe Claude Sonnet, I think 4.5, Claude Sonnet 4.5, and sometimes they tack on the, you can even tack on the cutoff date. I think there's a 2025. 09 or 229, yeah, something like that. So 29th of September 2005, that's the cutoff date for this model. So if you specify this, you don't actually need to prefix it with Anthropic. You don't need to say Anthropic. It will infer, this function is going to infer that this is an Anthropic model because these names are kind of unique to the model providers. The model providers don't have clashing names for their models. So same if you do Gemini 2.5, yeah, you're good to go. So yeah, this is how you set your model, or this is one way to set your model by using a string, or you can also use a base model object. You can use the base model object. One common way is to use the init chart model utility function from LangChain, where you can define, I'm missing the closing bracket here, where you can define your model, let's say GPT-4, or and this offers more settings. You can add more parameters, things like temperature, max tokens, and stuff like that. If you want to go that granular with your model definition, you can use init chart model. But if you just want to use the model as is without any extra configuration, you can just simply use the string. So like we did before, you can simply just say GPT-4o. Good. So the first item is the model. The second is the tools parameter. Now, as you may have guessed, this is a list of tools. So it's a list type. And what you simply do is pass in your tools, which are functions and functions that you've decorated with the tool decorator. So you use those functions, you put them in a list. Let's say tool 1. These are Python functions that have been decorated with the tool decorator. So this is where you put your tools so that the agent can have access to these tools, know that these tools are available for it to use for its operations. So that is tools. The next parameter is the system prompt parameter. The system prompt parameter. And this is where you pass instructions to your agent. This is where you pass instruction that defines what your agent does and tell it what task it is meant to handle, and sometimes what is the success criteria. And you can also few short it by adding examples and stuff like that. This is just where you instruct. This is where you instruct your agent about the function it is to perform. You define your agent behavior using this property. And this is just a string. This is like any common string, system instruction string. Is this 6 already? Yeah. So you can simply type in your system instruction here. You are an helpful assistant that has tools for baking cookies. Yeah. Sometimes you also want it to be aware of the tools it has, so that you can just be explicit with that instruction. Like, yeah, you have tools to do this, so you can do this. You can also instruct it on how to talk to the user, the tone to talk to the user in any behavior you want to bake into your agent. This is where you tell it. Now, the next parameter that we're going to be looking at is the response format parameter. The response format parameter. Now, this is where you configure your agent, or this particular agent, to use structured output or to produce structured output. So if you want your agents to produce structured output, this is where you do it. And this is very, very important, because most of the time, especially multi-agent systems, you would need your agent to provide structured output in order to interact with the other agents. Most of the time, you will need it to provide structured output so that the other agents can easily read what this particular agent is producing. And even sometimes to interact with other parts of your application, structured outputs are more native to your application's environment. So this is where you define your structured output, which can be done by using a pedantic model to define your schema. So we can say our structure schema. So you define that with pedantic, and you wrap that in a tool strategy instance. Did I spell that correct? Yes, tool strategy. So you wrap that in a tool strategy instance. This is the structured output strategy that is native to LangGraph, that is defined by LangGraph. You can also use provider strategy. Now, provider strategy, you have to make sure that the model and the provider support structured outputs, and it would enable them to produce structured outputs in the way that they have defined. So this one is provider specific if you want to align with what the model provider, or how the model provider interprets structured outputs. But don't worry, we'll be looking at all this in a very elaborate example that we're going to be building throughout this course. So yeah, tool strategy, and you pass in your schema. The next is context schema. The next property we're going to be looking at is context schema. Now, context schema, as you may have guessed, is where you pass in your runtime context. And this is very, very important for you to pass external information, metadata to your agent. You want to pass user IDs, you want to pass roles and permission information and stuff like that, user preferences. This is where you pass it. So context schema is where you inject all those properties which are going to be defined by a schema. So let us say context schema, which are going to be defined by a schema. And with this, your agent and tools can have access to that information. So context schema. Let me say context schema definition. Yeah. Next is state schema. State schema. Now, this function maintains an internal state. You know, as we've seen in all our LangGraph lessons, we always create a state schema for our agents. Now, this function already has that sorted out, but it only contains the messages parameter. The state only contains the messages parameter. Now, sometimes you want to add additional data to state. You want to add additional data to track within that state. This is where you pass it in. You pass in a state schema that inherits from agent state. is the class for the state of your agent. So you pass in your own custom state that inherits from agent state, where you've also added extra information. So if you want extra information in your state, you create a custom state. It inherits from agent state so that it can inherit that messages property and its reducer. And also you can be able to add your own custom information. Next, we have checkpointer, the checkpointer property. Checkpointer, and as you may have guessed, this is for maintaining short-term memory within this agent. So if you want subsequent turns of interaction with this agent to maintain context of the conversation history, you want to make sure that you add a checkpointer. So you can pass in any type of checkpointer based on your development environment. If you're in development, definitely you want to pass in memory saver. And if you move to production, you want to pass the Postgres saver. So depending on where you are, and you can also pass in the Redis saver if you would prefer that. So yeah, checkpointer for maintaining short-term memory. And the last parameter we're going to be looking at is middleware. Now, a lot of times you want to hook into the native behavior of this agent. This agent is abstracted. The behavior of this agent is abstracted from you, unlike the LangGraph graphs that we've been creating earlier, where we get to define all the nodes, get to define all our functionalities, all the edges, the flow, and everything. This one is totally abstracted. It just works using the React pattern. But sometimes you want to hook in to the process, and middleware helps you to do that. In this section, while we are building our project, we're going to be looking at how to swap models, how to even swap system prompts using middleware, handle errors and stuff like that. So middlewares are powerful when it comes to building this type of agents. This middleware parameter is really powerful, and we're going to be looking at how to use it in this section. So it's basically a list, and you can pass in as many middleware as you've created. If you have a middleware for swapping models, like I've said, pass it here. And in tool errors, you pass it here. Any type of middleware that is acceptable by this middleware parameter can be put in here. And all of them are going to operate as expected at different points of your agent's lifecycle. So these are all the parameters that are available. You have the model parameter, which you use to set the model that this agent is going to use, which is the brain of this agent. You have the tools parameter, where you pack in all your tools that are going to be available to this agent. You have your system prompt, that is going to be where you instruct your agent. You have your response format for your structured output, context schema for passing information, definition. So context schema for passing runtime information, state schema for creating a custom state, your checkpointer for your short-term memory, and your middleware for hooking into the behind the scenes interactions of this agent. So this is all the theory we need. Now let us learn by doing. In the next video, we're going to start creating a financial assistant, a personal financial assistant. That's going to be the agent we're going to create with this create agent helper. That's going to be our single purpose agent in this chapter, and we're going to be using it to explore the different parameters that are available for us using the create agent React agent builder. In this video, we're going to kick things off with our personal finance assistant agent. Yeah, that is the agent we're going to be creating using the create agent function. Now, this agent is going to be able to read our financial information, perform financial operations for us, and even give financial advice. Even though, disclaimer, I wouldn't advise that you take financial advice from an LLM, hook, line, and sinker. An LLM is a probabilistic machine. It doesn't have emotions. It doesn't have a soul. So it wouldn't really be able to totally consider your very nuanced and peculiar situation. So don't take financial advice from an LLM. But this is a fun project, and we're going to be looking at how we can use the create agent function to build up this single purpose agent. In this video, we're going to start the process. Let me start creating the file so that you know that I'm here and your screen is not frozen. So we're going to start in the project finance agent. We're going to be building the base agent, And progressively with each video, we're going to be adding more features and introducing you to more parameters that this function has available to us or provides for us, and how we can use them to achieve different levels of functionality in our agent. So yeah, let us start by creating the base agent. The first thing we're going to do is to bring in the create agent function from LangChain. So we say LangChain.agents import. Now, I've mentioned previously that an installation of LangGraph only comes with LangChain core. It doesn't come with the LangChain package itself that contains agents and chains and stuff. It only comes with LangChain core. So you want to make sure that you install LangChain. If you started your project by only installing LangGraph, it will not come with this LangChain. It will only come with LangChain core. So this has to be installed on its own. So yeah, just keep that in mind. So from here, we bring in our create agent, and then we need tools. We need to pass in tools. So I'm going to say from LangChain.tools import the tool decorator. So these are the two dependencies we need here. I think we can pull this to the side. These are the only two dependencies we're going to need here. No, I don't need Copilot. Thank you. Then the next thing we're going to do is to create our tools, the core tools for the base version of these agents. So let us do that. Like I said, you need to decorate a function, a tool function with the tool decorator. Now, the first tool we're going to create is going to be called get account balance, which by its name, you should be able to infer what it does. What it will do is that it will take a type of account. That can be a checking account, a savings account, or an investment account. You take a type of account, and it is going to return our account balance. So, going to write out a function. We're going to use dummy data. So I'm going to create a dictionary of account balances. So we'll say in our checking account, we have $2,500. In our savings account, we have $15,000. And in our investment account, we have 45K. Yeah, so this is the dummy balances that we're going to be working with. And the next thing we're going to do is to return the balance for the user based on the account type that is passed to this function. So I'm just going to say balance equals balances.get. We're passing the account type. Just pick it from here. And we'll say dot lower. And let us do some checking. If balance is not none, we'll simply return your balance or your account type. Account balance is, and we'll give it the balance. Then we're going to format that to 2 decimal places. The 2F, yeah. Good. So if the balance is not none, we'll return that statement. However, if they pass in an account that we don't know, that is, it's not amongst these three, we can simply say unknown account type. We display the account type that was sent, and we'll tell them the account types that we have. So the ones we have available are checking, savings, and investment. That's good. So this is our first tool, which simply returns our account balance based on the account type. Next, we're going to be creating another tool that is going to return the user's transactions. So if we give it an account type, it can return transactions in that account, and we can also give it a limit of transactions to return. So that will be called get recent transactions to also take in account type. Just copy that from here. Account type, choose a string, and we have a limit, choose an integer, and we want to limit that to 5. So 5 transactions at most. To also return a string. And here I'm going to bring in some dummy transactions that we can fetch from. So I'll just paste those here. By the way, these are available in the course repo, so that's where you can get this information. Wasn't a squiggly line here? Oh, okay. Yeah, good. I was missing an equal sign there. So these are going to be our dummy transactions. We have some transactions for checking. It has the date, the description of the transaction, and the amount. So electricity bill, restaurant, gas station, yada yada yada. Then for savings, we have some transactions also. Transfer from checking, interest payment, then investment, we have dividend, we have VTI, and based on the signs of the floats here, you can know whether it's a debit or a credit. So yeah, we have transactions for the 3 accounts, and now we can simply return transactions based on the account type and limit that has been passed to the function. So I'm just going to say account transactions equals, just copy transactions here and collapse it so that you can see things clearly. So transactions.get, we pass an account type and say dot lower. And if we don't have anything, just give us an empty list and limit this to the total, or the total amount that the user wants to see. So just limit that to that amount. So yeah, let's see if we got any. So if not, account transactions, then we simply want to return no transactions found for the account type that was passed in. But if we do get some results, we want to say recent transactions for the account type. Put a new line here, and then we build that list of transactions. So I'll say for T in account transactions. For T in account transactions, we first want to sign our transactions properly. So if it's a credit, that is if the amount is greater than 0, so we want it to give it a plus sign, else just give it no sign, because we already have the negative signs there for the debits. So we get the sign correctly, and we can attach the transaction to our results and say plus equal the date of the transaction. I need to put the date of the transaction, then the description of the transaction, and then what next? The amount itself, which will start by giving it a sign, then the $sign, and the amount. Do we already have the amount on the transactions itself? Oh yeah, they don't have. Okay, so put the $sign, and we just say T amount. Okay, T amount, and Let us format this. Good. Let's put a new line here so that every transaction is on a new line. So yeah, we get this result and we simply return it. So that's good. We return that back to the function. We have our second tool. Then let us create our third tool. Yeah, we're going to be having 3 tools. The third tool is going to help us plan a budget. It's going to help us plan a budget. So what this tool does is that it can take a monthly amount that we earn, and based on that amount, it's going to use something called the 50-30-20 rule to help us slice and dice it across all our responsibilities and bills. The 50-30 rule is a budgeting rule. It's a simple budgeting rule guideline that splits your after income task into basically 3 categories. So it puts aside 50% for needs. That's essentials like housing, groceries, utilities, and minimum debt payments. Then 30% for wants. Wants are your discretionary spending on dining out, hobbies, shopping, entertainment. Then it sets aside another 20% for savings and debt repayment. So things like investments, extra debt payments, and emergency funds. So yeah, it uses that to slice your monthly income and present a budget, a spending budget for you that you can use every month. So first, it will need to take our monthly income, which is going to come in as a float. Then expense category. Expense category. So you can just give it anything with your monthly income. Let's say housing. Say monthly income, let's say 7K. Then what should I spend on housing? Monthly income 3K. What should I spend on food? And it will tell you, yeah, spend this amount on food based on the 50-30-20 rule. So first, I'm going to bring in an allocations object that does the splitting based on the 50-30-20 rule that we just described. So I'll just paste that here. As you can see, housing 30%, food 12%, transportation 10%, utilities 8%, savings 20%, entertainment 5%, healthcare 5%, and others 10%. So now we can simply return what percentage of the monthly income should be spent on a particular item. So say percentage equals allocations dot get. Then we'll pick the expense category, make it lowercase. Then we'll say if percentage is none. So if we can't find it in the budgetary breakdown, then we'll say that, yeah, we don't know this category. Unknown category. I will pass in the expense category. Then we also tell it that, yeah, the ones we know, the categories that are available are these ones, which we're going to list with commas separating them. So I'll say dot join. I'll just simply take our allocations, and I'll say dot keys. So these keys, housing, food, transportation, yeah. So just list them in a comma separated manner. So that's if we cannot find the particular expense category. But if we do find it, then we can say that our recommendation will be the monthly expense, just get that, or the monthly income rather, monthly income multiplied by the percentage. That's what we got here, the value of the expense category. So multiplied by this percentage, then we can return recommended and say for this expense category, the budget we are recommending for this category is $, and we pass in recommended, and also format it, and we say per month, and this represents a certain percentage of the income. Say percentage multiplied by 100. Let's format that to .of. Good. And we can put our percent sign here and say of income. Okay, so that's good. That's our final tool. So we've gotten our tools ready. These are the three tools that represent the three functions that the model can perform. And now we can move to the next thing, the next core thing to our agent, which is the prompt, the system prompt. Now I'm going to bring that in and paste it here. Like I said, you can get all these things from the exercise files, so just go to the repo for this course and get the prompt from there. And you can also write your own prompt. You can get creative and write your own prompt. Yeah, feel free to write your own prompt. That would even be a very good test of your knowledge on what we have been doing so far. So I'm going to paste the system prompt here. Now this says you are a helpful personal assistant. So we define its role. Your capabilities: check account balances for checking, savings, and investment accounts, view recent transactions, calculate budget recommendations. Like I said, sometimes you want to get explicit by telling it the tools it has. Now, guidelines: be helpful and informative, provide clear, actionable advice, use tools to get accurate information before responding, and format monetary values clearly. So, these are the instructions. This is the role. And we also give it the tools, and we told it how to behave and some of its goals. We have our system prompt in place, and now we can build our agent. So let us come down here and say agent equals. Then we take our create agent function, and we give it three core parameters. First is the model, which is the brain. And for this, we'll just say use GPT-4o. The next thing is the tools, our tools. That is the next core thing to an agent. And we have three tools here to give it. Get account balance, get recent transactions, and calculate budget. Perfect. We have our tools in place, and the final thing to give it is the system prompt. Using the system prompt property, I will set that to our system prompt constant. Awesome. So now we have this in place. We can now run it with an example. I'm going to create a function that we're going to be running. It's going to be our main function. So I'm going to say def main. This is the function we're going to be running for our examples in this section for this particular agent. I'm going to paste in some print statements to signify that, yeah, this is our simple financial agent, and we're in stage one. Stage one meaning that, yeah, this is the base. This is the base version, the base model for this agent. So we get that, and we want to run this function if this file is run directly. So say if name equals main. So if we run this file directly, run the main function. Else it is going to serve as an import into another file. So this is good. Now let us write our example. So this is going to be test 1, and I'm going to be naming my tests: test 1, test 2, test 3, so that we can see the progression of the agent's capabilities. So I'm going to say test 1, and test 1 will be to just check our balance. And we'll say balance message equals, that's going to say what's my checking account balance. So we're asking the agent about our account balance, and we're being specific. So down here, let's put a print statement. We'll just say have and say query. That'll be balance or balance message. So our query is balance message, and we can invoke our agent. Now, our agent, if you are familiar with the LangChain way of things and even the LangGraph way of things and everything, these are runnables and you can invoke them. To run them, you invoke them. So say invoke. And like I said, for the state, you invoke them with the initial state. And the state of an agent using the create agent function contains just the messages channel. Contains the messages channel. This is where it keeps your messages tree and just manages your message, and a reducer is attached to it automatically to manage the adding and removing of messages. So we say messages and we give it its first message, passing a list. Even though we want to give it a single message, we'll still have to pass in a list because we might want to give it multiple messages. So here I'm just going to give it one message with the role of user, and the content is going to be our query, which is balance message. Our query. And down here, we can simply say print. And I'm going to make it an F string. Add an agent emoji here, because I love how this helps us to see our examples clearly. So agent, and this will be response. Then from the response, we go into the messages. We pick the last message, which is the response that just came from our LLM. Sorry, messages, am I writing that correctly? We pick the last message, good. Then we get the content parameter. So yeah, just simply dig into the messages in state. You pick the last one and you get the string representation here. So this should give us our result for the first test to check our balance. Let's run that and see. Put up on command line. Now make sure that your OpenAI key is set in place, or any of the models you choose to use, whether it's Gemini or Claude. Here we're using GPT-4o, which is an OpenAI model. So you want to make sure that the appropriate environment key for your particular model or model provider is already in the terminal session. So here I'm going to run our agent by saying Python 05 single purpose agent, and we're going to run our finance agent and hope that there are no errors. Let's run this. So we get an error here that says LangChain call, no module memory, but I believe I know where the problem is coming from. I'm just starting this recording, so I basically forgot to activate my environment. So let's do that. Yeah, vmv/bin/activate. Okay, so I didn't activate my virtual environment. That's why we got that. So let's just run this again. So now we get another error that says function must have a doc string if description is not provided. So yeah, I also committed another blunder for tools, which is the fact that you need to document them. So I didn't document these tools. So let's just do that. For this one, we'll just say get the current account balance. So for tools, you have to first make sure that the arguments are typed and also provide a very good description. So yeah, it's showing that it is very, very important. It is not a nice to have. So say get the current balance for a specific account. And I'm just going to add an argument section. Let's say args is account type. I think that's the only argument here. By the way, some tools may not have any argument, as we're going to even see that later on. There are some tools that don't have any argument that are specific to the user's request, but they're still taking the runtime. So here we have check-in, we we have savings, and we have investment. Okay, so yeah, description for this, then description for this other one. I would just say get recent transactions for an account. And for the argument, we have account type. We just type of account. That can be savings, investment, or checking. And limit is going to be number of transactions to return. And default is 5. Okay. Next, for calculate budget, let us say calculate recommended budget allocation for an expense category. Okay, and the arguments are your monthly income, which is the user's monthly income. User's monthly income and expense category. Just copy that from here. This category is going to be category. Okay, so I hope the two gods are happy now. We now have descriptions. Now let us run this once again and hope we don't have any errors this time. Or if we have any errors, we'll still fix it. It's part of the whole development process. So yeah, what's my checking account balance? And it says your checking account balance is 2,500. If you need any further assistance or details about your account transactions, feel free to ask. So it takes our results from the tool, it reformats it its own way because the model is still going to try and summarize or expatiate depending on what we are inquiring about. And it still tells us, prompts us about another tool that it has. So it says if you need to see your account transactions, feel free to ask. That's amazing. So our agent is working fine. But let us see more examples. Let's see more examples. So I'm going to bring in an example that uses more than one tool. This one uses the get balance tool. Let's look at an example that uses more than one tool. So I'm just going to come down here and paste this new example. So this is a multi-tool query. It says show me my savings balance and recent transactions. My savings balance and recent transactions. It points to a particular account, requests for this balance, and it wants the recent transactions. And the agent is smart enough to know that, yeah, the recent transactions in the savings account, not the checking account, not all the transactions, in the savings account. So we pass that in, we get the final output. Now let us see what we get. I'm going to comment out this first test and just run the second one so that our results don't clash. So pull this up. Let's run this. Once again, it says show me my savings balance and recent transactions. And it says your savings balance is 15K. Here are your recent transactions for the savings account. You see, it specifies, it got that it's a savings account and it picked that. So we had an interest payment of $12.50. And we transferred from our checking, we transferred $500 to our checking, from our checking account rather, into the savings account. So, awesome. Let us look at the third example. And this time, let us make use of our budgeting tool. So, just going to bring that example in. First, let us comment this out. Let's come down here and bring in our third example, which is budget calculation. Now this prompt says I make 5K a month. How much should I spend on housing? So give it to our model, we get the results. Now let us see it in action. 5K a month, how much should I spend on housing? Says for a monthly income of 5,000, it's recommended to allocate about 1,500 or 30% of your income towards housing expenses. This budget includes rent or mortgage, utilities, and any other housing related costs. How amazing is that? So we've been able to build the base version of our financial personal assistant. It contains some helpful tools and we're getting useful information from it. And in the subsequent videos, we're going to be building on this base agent, adding more features and introducing more parameters to the create agent function.